Okay, boys and girls, I'm going to start another class on physics. I'm going to start a new chapter, that is chapter number 12, and the name of the chapter is here Magnetic Effect of Current. I repeat, the name of the chapter is here Magnetic Effect of Current. This is a new chapter, and that the name of the chapter is here chapter number 12. Before discussing this topic, at first I need to know what is called magnet. What is called magnet? IP boys and girls, magnet is a special substance which can able to attract iron and ionic substance. Okay, magnet is a special type of substance, a special type of ionic oxide which can able to attract iron or iron type substance. Okay, so these substances are called magnet. So the substance which can attract iron is called magnet. I can write down here the substance, the substance which can attract, which can attract, attract iron is called, is called magnet. It's called magnet. Listen to me, boys and girls. Magnet can attract iron. Okay, iron, nickel, cobalt. Magnetic substance. Listen to me. My next topic is here magnetic substance. Magnetic substance. Boys and girls, the substance which can be attracted by magnet and which can be converted into magnet. Listen to me. The substance which can be attracted by magnet and which can be converted into magnet is called magnetic substance. Okay, so in this part you know that the substance, the substance, substance which can be, can be attracted, attracted by magnet and which can be converted, converted into magnet is called, is called magnetic substance. Is called magnetic substance. Okay, so the substance which can be converted into magnet and which can be attracted by magnet. Okay, so this type of substance is called magnetic substance. Okay, for example, for example, for example, iron, iron, cobalt, nickel, etc. Okay, so this substance, this substance can be converted into magnet and this substance can be attracted by magnet. Okay, so that's why those are called magnetic substance. Now the next day I'm going to discuss about non-magnetic substance. Non-magnetic, magnetic substance. Listen to me. Non-magnetic substance means here this substance cannot be converted into magnet. I repeat, this substance cannot be converted into magnet and this substance doesn't attracted by magnet. So in which way I can give the definition? I can give the definition just like this process. Okay, that is the substance which cannot attracted by, cannot be attracted by magnet and which cannot be converted into magnet. So these two can, in the definition of magnetic substance, these two can, listen to me, if I mark it, these two can is replaced by cannot. This to can is replaced by which quantity? By cannot. So I can say that this can is replaced by cannot, and also this can is also replaced by cannot. Okay, that's why that substance or those substances are called magnetic substance. So I can say that the substance, substance, substance which cannot be attracted by magnet magnet, and which which cannot be cannot cannot be converted converted into magnet is called what it does is called non-magnetic. It's called non-magnetic substance. It's called non-magnetic substance. Now what it does? So which one is called non-magnetic substance? I can say here the substance which cannot be attracted by magnet and which cannot be converted into magnet. Those substances are called non-magnetic substance. For example, for example, for example, gold, or gold, silver, copper, zinc, etc. Those are metal. Okay, those are metal. You can say, sir, those are metal. So why though that are not a magnetic substance? Because these substances are metal. Okay, it's very good. Those are metal. They have free electron, but they cannot attracted by magnetic substance, magnet, and they cannot be converted into magnet. That's why these metal are called. Listen to me. These metal are called non-magnetic substance. There's some other example of non-magnetic substance. Those are plastic, wood, paper. Okay, uh, those are called non-magnetic substance. Okay, and then in next step, I need to know how can I convert a magnetic substance into non into magnet. Listen to me. Next step, I'm going to discuss how can I convert a magnetic substance into magnet. Listen to me. To convert a magnetic substance into magnet, there are two processes. One is induction process, a rubbing method, and another is by electrical method. Okay. So in class 6, it is discussed very detailed that about a rubbing method. But in this chapter, the name of the chapter is here magnetic effect of current. That's why I'm going to discuss about the electrical method of magnetization. So magnetization in electrical method. Listen to me. So in this case, I used a new word that is called magnetization. 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 So magnetization means what? Magnetization means to convert a magnetic substance into magnet. The process is a process. Okay, it is a process to convert a magnetic substance into magnet. When you want to convert a magnetic substance into magnet, the process that you used That process is nothing but uh, it's called magnetization process. So magnetization process is a very special type of process. By this way, we can convert a magnetic substance into magnet. So in this step, I'm going to discuss about magnetization process of electrical method. Now, I'm going to take a iron bar, metallic iron bar. Is a iron nail, a piece of iron. Okay, I'm going to take here a piece of iron. So in this step, I'm going to take a piece of iron. Okay. Now, boys and girls, now pointing this iron by using some electric wire like copper, and this electrical wire must be free from any kind of plastic wrapping. I repeat again, this electrical wire must be free from any kind of plastic wrapping. Okay, this is a pure plastic. This is a pure copper wire, and then connecting a electric battery or cell, with this connection, this setup, with this connection or with this setup. Okay, then connect a battery with it. When you turn on your battery, you see that you can say that this is the positive terminal and this is the negative terminal. Okay, and this part supplies current. So electric current I supplies electric current I in the circuit. Okay, in which case when you open or turn on your circuit, okay, so when you turn on your circuit, then you see that this this metallic bar converts into magnet. Listen to me, this metallic bar converts into magnet. So when this metallic bar converts into magnet, the process that used here to convert a magnetic substance into magnet is called electrical method of, listen to me, electrical method of magnetization. What? Electrical method of magnetization. Okay, the long time you can pass electricity into this iron bar, the duration time, you can say that this iron bar converts into magnet. Okay, so this is called electrical method of magnetization. Now, in next step, listen to me. Now, in next step, I'm going to introduce with you an experiment that is executed by scientist Weierstedt. That was executed by scientist Weierstedt. Okay, and this is known as scientist Weierstedt experiment. And this experiment indicates you that when electricity passing through any electrical wire, I repeat, when electricity passing through an electrical wire, then because of this electricity, this wire converts into magnet. And this is called magnetic effect of current. This is called what? Magnetic effect of current. I repeat, when electricity passing through any electric electric wire, okay, this may be copper wire, this may be silver wire, okay, any kind of electric wire, then you see this electric wire converts into magnet, okay, and this is known as magnetic effect of current. And this concept at first introduced by scientist Weierstedt by his experiment that is called Weierstedt experiment. So in this case, I'm going to discuss about Weierstedt experiment. Okay, Weierstedt first took a piece of paper. Okay, this is a piece of paper, and then you make a hole at the middle part of this paper by using a copper wire. So this XY, listen to me, this XY is a copper wire. Okay, this XY is a copper wire. So by using this copper wire, you make a hole at the middle part of this paper perpendicularly. he make a hole at the middle part of this copper perpendicularly. Okay, so he make a hole at the middle part of this paper. Okay, then he kept some sand. Listen to me. He kept some sand having a very small iron particle. He kept some sand having very small iron particle. It looked like a black sand. Black sand. Okay, you know that there are different types of sand in our environment. So the sand, which one contain a huge number of iron particle, it looks in black in color. It looks black in color. Okay, so he took some sand that must be black sand. Okay, it does indicate that that sand having a huge number of iron particles. After some time, he passed electricity inside this copper wire. He passed electricity inside this copper wire. Okay, and then when he passed electricity inside this copper wire, then he saw some amazing thing. He saw some alignment of iron particle around this paper, just like this. Some alignment of this iron particle around this paper, just like this. Okay, this thing indicates you that, listen to me, this thing indicates you that what, when electricity passing through any electrical wire, when electricity passing through any electrical wire, then this electrical wire can able to create a magnetic field around it. This electrical wire can able to create a magnetic field around it. Okay, the reason behind this alignment of this iron particle is the main thing, that is when electricity passing through this iron particle, then this iron particle becomes magnetized. Becomes what? Becomes magnetized because of this electricity. Because of this electricity. Since iron particle here are the very small iron particle, since iron particle are here are the very small particle, okay, that's why this iron particle stands around the copper wire, just like a small circle, just like creating a circle. Okay, and this circle indicate that because of this alignment, because in this alignment indicate copper wire can create magnetic field around it. Copper wire can create magnetic field around it. Okay, and this is the first experiment which demonstrate that, which indicate that a copper wire, a current carrying wire, can create magnetic field around it. I repeat, a current carrying wire can create magnetic field around it. Okay, so where is that show that a a current a current carrying wire can create, can able to create magnetic field around it, around it. Okay, so boys and girls, thank you very much, thanks to all. Okay, in my next class I'm going to discuss about Faraday's law. Thank you very much.